Hello, and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Andrew McKenzie-Gopsill of the Charlottetown Research and Development Center of Agriculture and Agri-Food Canada. Buckwheat can be a powerful driver of ecosystem services in potato rotations grown in Canada, but with its long-lived seeds and ability to make a whole lot of them in a short time, it can also pose a serious volunteer problem. In this episode, Andrew joins me to discuss how creating a framework to reduce volunteers can help keep this helpful plant from turning into a fearsome weed. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Andrew McKenzie-Gopsill with us. Andrew completed his PhD in weed science at the University of Guelph under the guidance of Dr. Clarence Swanton, studying early season weed competition in soybean. Following graduation, Andrew worked as a postdoc with Dr. Swanton before accepting his current position in 2016. At Agriculture and Agri-Food Canada, Andrew's research focuses on the development of novel weed management tactics, cover crop management, and the biology and ecology of weeds in Atlantic Canada. Hello, Andrew. Welcome to the show. How are you doing today?
Good. Thank you for having me.
Yeah, we are thrilled to have you. So today we are talking about potato, which we don't normally talk about on this show, so I'm very excited about this. So I didn't realize that potato is like a big deal in Canada. So can you tell us a little bit more about the potato situation in Canada and some of maybe the difficulties that farmers face?
Sure. So, potato is, it's not one of our main crops, and Canada wouldn't rank in the top probably 10 in terms of worldwide potato production. But it is the most economically important horticulture crop to the Canadian economy. Potatoes are grown all the way across the country. I work in Atlantic Canada and Eastern Canada in Prince Edward Island, and potatoes are kind of synonymous with Prince Edward Island. The famous PEI potato. There's a couple of things we're known for: Green Gables and potatoes and French fries. So really important to our economy as well as our neighboring province, New Brunswick. Um, and we're mostly doing chip stock, French fry potatoes, that type of thing, rather than fresh market potatoes. Some of the other provinces in Canada, kind of in central Canada, Ontario, Quebec, they're more would be fresh market potatoes, and then we have more processing potatoes occurring out in Western Canada. Places like Manitoba and Alberta have pretty good and strong potato industries. In terms of acreage, it's kind of spread across the country. Around 30 to 40% in any given year is in Atlantic Canada, so in New Brunswick and Prince Edward Island, and then about 30% in Manitoba, and then about 30% in Alberta. We grow potatoes a little bit differently in Atlantic Canada, where it's all rain-fed systems versus out west it would be all irrigated, and a lot of areas where they grow potatoes in the U.S. and they would be under irrigation as well. But we'd be more similar to kind of production practices that might be happening in Maine, which would also be rain-fed potato production. Um, in terms of main threats for potatoes, um, we deal with, I'm a weed scientist, so we have kind of widespread herbicide resistance. In our region, there's really only two herbicides that are used in potatoes for the most part: metribuzin or Sencor, and then Linuron or Lorox. I think it has a different trade name in the US, but those are really the main two herbicides, and we have widespread resistance. Probably 40–50% of our fields have a resistant weed in them, primarily common land squatters, but also red root pigweed. Um, Not sure about the situation in the other regions of Canada. There's really nobody tracking it in potatoes. I'm really the only potato weeds guy in Canada. Um, but I'm sure they're dealing with some of the same challenges. We're also, potatoes are very tillage intensive. There's a lot of soil disturbance. And so we've seen a shift, at least in our region, where we're reducing the frequency of cultivation. So historically, potatoes would have been planted, um, and then about 4 weeks later, or within those first 4 weeks, we would have been putting a hill on top of them. So you're getting some mechanical cultivation, and then you put your herbicide on it at the end after those 4 weeks. But at least in our region, we're doing more and more hilling, putting that final hill on at planting. So we have what are called basket hillers on the back of our planters, and we're planting and hilling in that same operation, applying our herbicide about 4 weeks earlier than we could, and really asking a lot more of it. So it's really driving a lot of some of those challenges, at least weed challenges that we're facing. But potatoes have tons of other challenges. Lots of disease pressure, lots of insect pressure.
The other major problem pest, at least in our region, would be wireworms, which is the larvae of the click beetle. And so they live in the soil and um, they come up through the soil profile shortly after planting, and then they munch away on the tubers. And it introduces all these holes into the tubers and makes them unmarketable. So um, up until a few years ago, we really had no good insecticides. Some of the neonicotinoids would provide kind of a barrier, but it didn't last all season, and it would really just cause the wireworms to kind of come up. They'd hit that neonicotinoid barrier in the furrow, and it would knock them out, and they'd wake up a couple of weeks later, ready to munch away on the tubers. Um, so we've since now developed. There's a new insecticide on the market that provides pretty good wireworm control. So that's kind of mitigated some of that issue, but it's still a major problem in our area. So those are kind of some of the main challenges facing potatoes in Canada right now.
When you mentioned that there's only two herbicides used in potato, is that because there's already resistance to the other ones, or is it just those are the ones that work in your region and kind of set up?
Yeah, it's more of just a producer's familiarity, and those ones fit well in our rotations, and they just don't seem to be. They've gotten away with just using that more simplified management practice. We've tried to introduce some more complexity, greater tank mixes, introducing different modes of action, and some producers do it, but yeah, not just it just seems to be kind of the standard management practice. We also do have quite a few seed potatoes grown, and those seed potato acreage, again, it really limits your herbicides. Some of those other herbicides you can't really use. The other challenge is around our soil. So we have very low organic matters in sandy soil, which can limit your effective or your use of some of like the group 15s, things like S-metolachlor or dual 2 magnum. They have some of those restrictions are related to soil, so that can kind of limit some use on some of our acres.
Sure. Yeah. No, that totally makes sense. So that is kind of where some of your work is coming in with maybe finding some alternatives and maybe seeing what cover crops can do. So buckwheat is the one that we are talking about today. I've heard of buckwheat, but I don't really know anything about it, and I wanted to kind of come in fresh and not look it up beforehand. Also, transparency, I just forgot and didn't, but I usually don't. So that's a great opportunity for you then to explain like what does it look like? How does it seed? I know you mentioned there's kind of some difficulties with the seeding times in it in the growing season. So yeah, I would love an overview on all of that, kind of what you're using it for, how to terminate it, what's going on with buckwheat.
Sure. So buckwheat is it's a fantastic weed suppressing cover crop. But it also has a whole bunch of other benefits. So it's a really short season crop as well. So that lets us plant it kind of multiple times and get multiple benefits out of that crop. So buckwheat, I mean, it can be used. It's a pseudo cereal. It grows as just generally a single stalk. The seeds look very similar to wild buckwheat or any of those other Polygonaceae or species where it's a three-sided seed. But a little bit bigger than a wild buckwheat seed, black, it's a three-sided, produced on really the ends of the flowers that are at the tops of the plants. On these white flowers, it has kind of spade-shaped leaves and forms a pretty dense canopy. Bees love it. If you ever go into a buckwheat field, the whole thing will be just buzzing. What we're using it for, though, is originally, because we had this challenge with wireworms and the lack of effective insecticides, our entomologist here, Christine Nerona, in collaboration with some of our colleagues out in BC, British Columbia, who also have some of the same wireworm challenges, they discovered that you could grow buckwheat or brown mustard as a cover crop in the year prior to potatoes, and they saw a reduction in wireworm populations. So what they've since found is that the wireworms will come up through the soil profile and munch away on the buckwheat and the brown mustard roots. and then it gets converted into toxic compounds into their gut and will kill them. So they developed this practice where we would double crop these cover crops. So we plant the first one in around kind of mid-June, after most of our other seeding operations from our main cash crops have been finished, and then we terminate it 4 to 6 weeks later, plant another crop in maybe about 2 weeks. That second crop would occur sometime mid-August, and then we would allow it to frost kill out, because both those crops, especially buckwheat, highly sensitive to frost. As soon as it gets anywhere close to 0 degrees, it just kills, or it frost kills out. And so in terms of termination, we would just mow it off. We would seed it, mow it, and just leave it there. And then the same crop, we would just go and seed it right back on top. So we're just using mowing for terminating. They did evaluate whether or not disking it in improved any kind of control, and didn't really seem to see any effect there. So it's really, as long as those roots are there for the wireworms to munch on. And so that's really what led the drive of and the adoption of buckwheat. And we started seeing huge amount of acreage of buckwheat across Prince Edward Island. We've kind of shifted away from some of the brown mustard. They seem to show the same effectiveness on buckwheat. The brown mustard, we started to get some really high levels of flea beetles, basically resulting in we can't grow brown mustard anymore. As well as the seed cost is quite high. Compare that to buckwheat, where we don't have those same pest issues, as well as quite lower seed costs. In terms of other ecosystem services that buckwheat can provide, as I mentioned, it's really good at suppressing weeds. If you get a good crop of buckwheat down, you basically have no weeds growing underneath it. So really providing a good level of weed suppression, as well as it's been shown to increase phosphorus availability in rotation. So compared to some of the other kind of classical rotations that we have in Prince Edward Island, which the most common is a cereal underseeded to a legume, typically red clover. And so that's in your first year. You harvest that barley, then you let that red clover grow as essentially a green manure in that second year, and then plow it in for nitrogen credit to your potato in that third year. So they're replacing a lot of that red clover year, which is another source of another food source for wireworms. So they're replacing that red clover year with some of these other cover crops like buckwheat grown in the year prior to potatoes.
Yeah, that sounds great. Really packing a punch. Also, shout out to wireworm eating things that are bad for you until you get a stomachache, because it's just so good. Relatable, relatable wireworm. Been there myself quite a few times. So one of the kind of issues that you are running into with this buckwheat, as much as it is very helpful, seems to be these kind of volunteers of buckwheat that are cropping up, pun intended, I suppose, when you don't want buckwheat hanging around. So could you tell me a little bit more about that, and then how that relates to the research that we are discussing today?
Sure. So even though buckwheat has all of these great benefits, one of the challenges with it is a very short season crop. And what we found is that even though producers are doing their best to manage it in this double cropping system, terminating it, 4, 5, 6 weeks after planting, we're still getting a lot of buckwheat volunteers. And volunteer buckwheat is becoming one of the most common broadleaf weeds that you see in potato fields across Prince Edward Island. In terms of our management strategies, most of our herbicides are not going to be effective on it in potato. And it seems to just kind of emerge continuously. So even if you do and go and cultivate, you're still going to get emergence later on after that final cultivation. So it's really becoming quite a problem. And producers are moving away from buckwheat when they discovered that, it seemed to be volunteering in one of their fields. Then they're less apt to grow it in their rotations and not getting some of those same cover crop benefits that we would be seeing. So it's the how quickly this thing can produce seed. The other component is that the seed seems to be very long-lived. We haven't done any studies on seed longevity, but just from some of the digging into the literature, found around 5% decline in viability per year. So this seed is going to be kicking around for a very, very, very long time in our systems.
Wow, I am shocked by that number. That's very long-lived. So one of the things you also mentioned is that there's kind of this like late/variable seeding time. So if I'm remembering correctly, and if I'm not, just please correct me. It seems like it's not very easy to know like when to terminate because you want to get the benefits, but like you're not sure when the seeds are gonna happen, or maybe I don't know. Tell me more about that.
Sure. So we kind of have the first seeding time I think is better established. Like we seed it when we're finished on all the other seeding of our cash crops, and then terminating them. I think it's probably again easier to get in to terminate it for that kind of July termination, just because there's fewer things happening on most farms at that point, or in our potato farms. It's that second seeding time. So it's happening kind of when they get an opportunity in August, and then they're relying on that on a killing frost to terminate it. And so if you look at our last frost date for Prince Edward Island, it's around, first frost date, it's middle of September usually, but we're seeing more and more where we're not getting that frost until into October. Or this year, I don't think we had a killing frost until the first week in November. And so we're getting all of that extra growth opportunity, and that's happening at the exact same time when all of our producers are out harvesting potatoes. So they have no ability to go in and potentially terminate that thing. They're just relying on it to be frost killed. And especially just with our variable weather and changes, we're just not getting necessarily that frost happening a lot earlier in the season. So it isn't being terminated, essentially.
Sure. Yeah, definitely would pose a danger there. So the goal here was kind of try to develop a framework for some of the timing to help avoid winding up with future volunteers. So there are 2 acronyms that I will probably continue to screw up throughout this interview, so apologies in advance. But they are CPWC and CPWSC. So I would like to know a little bit more about how those are defined, what they are and how they work, and then tell us more about your experiment and how you went about this work.
Sure. So the first one, the CPWC, is the critical period for weed control. So that's a concept that's existed. I think it was first developed in the 60s, worked on quite a bit by my supervisor, Dr. Clarence Swanton, and still constantly being developed by Stephen Knezovic in Nebraska and lots of other researchers across the country. And what this is a framework and a tool that producers can use to time weed control efforts and identify when weeds are going to have the most negative impact on yield. So the way we do that is we set up 2 different experiments. One experiment where we have our crop growing with weeds for different durations of time to determine how long weed competition needs to be to impact yield. And then we have another experiment where we keep our crop for increasing durations of weed-free or weed-free durations before allowing weeds to compete. And that tells us how long we need to keep our crop weed-free to start the season to maintain yield. Effectively, the way this works, it's really the basis for start clean, stay clean. We want our crops to emerge into a weed-free environment and then stay weed-free for a certain period of time. And that time becomes what we call the critical period for weed control. We define it as kind of a set threshold. Usually would be about a 5% yield loss due to weeds. And so we say as long as we control weeds during this time, we will get 95% of our yield. All else being equal. So weeds that emerge later on in the season aren't necessarily going to impact yield. They might have other reasons why we want to control them for seed bank management, harvestability, etc., but they're not going to necessarily impact our yield. It's really those early emerging weeds that have the biggest impact on crop yield. So that's the first concept. The second one is the critical period for weed seed control, the CPWSC. And so that's a newer concept developed by my colleague Charles Geddes at Agriculture Canada in Alberta, and then Adam Davis at University of Illinois. And so they took that critical period for weed control concept and flipped it and applied it to a weed. So instead of trying to minimize yield loss, they're trying to minimize seed production. So trying to go at the other end of those curves. They're setting up an experiment the exact same, where we're determining which emergence cohort, so which planting time, determine, or when those seeds start to, or when those plants start to produce viable seed based on planting or emergence time. And then another experiment where we're determining when do we have to harvest them and how late can they grow again before they produce viable seed. So we have these two concepts, the critical period for weed control, critical period for weed seed control. And what we've done is taken them and mashed them together and applied it to a cover crop. And so in terms of critical period for weed control, we've taken that and applied it to biomass production because we want to produce as much biomass as we can out of our cover crops. So we're trying to determine how long do we need to grow this cover crop for, and when do we need to terminate it to maximize the amount of biomass we're going to get, because that tends to be tied to the various agri-ecosystem services we're looking for. Then we took the critical period for weed seed control concept and again applied it to a cover crop, in this case buckwheat, trying to reduce the amount of viable seed that's being put into our system for all the reasons we just talked about. So we're taking these two ideas and putting them together and applying both of them to a cover crop to try to come up with what we call the critical period for cover crop management. So we set up two different experiments, very similar to how you would do, or really the exact same methodology that's been applied to these other concepts. So we have one experiment, which is we call our planting study, where we plant buckwheat at 2-week intervals all throughout the season. So in our experiment, we had 10 different intervals. So we started planting pretty early in the season, in spring, and then 2-week intervals all the way up until I think it was late August. And then we had another experiment where we planted all of our buckwheat at the start of the season, and then we harvested it every 2 weeks, and to determine how long do we have to let this grow before it starts to produce viable seed. And so our first experiment determines when we can plant it and at what timing, how early or late in the season we can plant it and end up with viable seed. And our second one is around when do we need to terminate it to produce or to minimize that viable seed production.
So there were a few different things that you were measuring here that I just wanted to define because some of them are pretty close in name. So could you tell me more about what you were measuring specifically when you were calculating these?
Sure. So at each one of these harvest timing, so in our harvest study at each one of those 2-week intervals, and then in our planting study at the end of the experiment at the end of the season, what we did was collected total above ground biomass of that plant. So we cut it at the soil surface and we took that entire biomass, dried it down to determine how much total biomass was there. But that biomass is made up of both vegetative tissue, so things like stems, leaves, flowered parts, that type of thing, as well as reproductive tissue, which is all of your seeds. And so we have these two components. So we have our total biomass, and then we separated them out to determine how much vegetative biomass was there, and then how much reproductive biomass or seed biomass was there. And then, so those were the two main numbers that we use to model all of our, or determine all of our time frames for determining biomass, vegetative biomass, and seed production.
Is it difficult to separate the reproductive biomass, or is that pretty like, oh, there it is, like snip?
Yep. So it's the same thing that would be happening in your combine. So your combine is just doing it all for you and then throwing it back onto the field. So we just did it by hand. So it's just hand threshing, especially for buckwheat with a pretty big seed. It's just running it over some sieves, and then we end up with all the vegetative tissue, the reproductive tissue left over.
Yeah, that's great. Always love to have it be easy, because that's a lot of work. Hi everyone, I hope you're enjoying the show. Interested in learning more? Andrew's paper, The Critical Period of Cover Crop Management, a framework for maximizing biomass potential and minimizing volunteers with buckwheat, published in Agronomy Journal, is always freely available. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Thank you for being our sponsor. Let's get back to the show. So, what did you find?
All right. So, overall, we found that we could maximize how much biomass we produced from buckwheat by growing it, planting it early in the season, right around the start of May, second week of May, And if we let it grow for approximately around 3,000 growing degree days, and I can explain that in a second, we got about 4 tons per acre of biomass, which is way higher than any other estimates of buckwheat. We've been using and working with buckwheat for quite a few years now, and we've never been able to produce this amount of biomass when we let it grow for the full season. And I mentioned that growing degree day concept. So we wanted to get away from trying to just define this based on actual days, because when you're doing any kind of time measure, it's based on what environment you're in, and buckwheat is going to grow based on how much temperature and how hot and cold those days are. So growing degree days is a way to measure time based on temperature. And so we chose a base of 5 degrees Celsius or 41 degrees Fahrenheit because any temperatures below that, buckwheat really can't grow. That's really that critical temperature that it needs to progress through any of its physiological development. And so each degree that you have above that base temperature, that threshold temperature, in this case 41, accumulates 1 growing degree day on that day. So in terms of us, we're getting it's around 15 to 20 growing degree days. That's based on Celsius. 30 and 40 growing degree days based on in terms of Fahrenheit per day. So if we let it grow for that full season, we can get up to upwards of 4 tons per biomass. If we still sowed it early in the season, but we terminated it early in July or later in July, if we terminated it earlier in July, we got about 50% of our total biomass, so around that 4 tons per hectare. But if we waited till the end of July, we'd get upwards of 90% of the total biomass. So we're looking at around 480 to 1,000 growing degree days of growing time, and able to produce quite a significant amount of that total biomass. In terms of sowing time, if we sowed it earlier in the season, we were able to get good amount, high levels of biomass. But as we delayed it, we obviously saw a pretty rapid reduction. And if we sowed it around kind of the mid-August, second week of August, we were only getting about 25% of total biomass by the end of the season. So that's all in terms of total biomass. All of our vegetative biomass numbers were very similar and kind of trended all similar. They're made up of the same thing. We just have a wider margin of being able to produce that same amount of vegetative biomass. So you have a bit of a more leeway on some of those numbers. So you're able to seed it maybe a little bit later, terminate a little bit later, and still get the same level of vegetative biomass.
Before you move on to the like other side of that with the seed control, is there like a cap on biomass where it's like anything above this is like not really adding any benefit as far as like the ecosystem services you're looking at?
I guess it all depends on the one thing just that comes to mind is that with more biomass, then you have more residue to manage. So that could definitely cause some challenges for subsequent crops. Less so for something like potato, where we're doing quite intensive soil tillage and disturbance. But yeah, I think at least the thing that comes to mind for me would be around residue management in that subsequent crop. Fortunately for something like buckwheat, the residue does degrade quite quickly, so it's not going to be sticking around there and potentially interfering with like seeding operations or subsequent herbicide applications or anything like that. Yeah, I'm not too sure. Generally, I wouldn't think of less biomass being a problem.
Sure. Yeah. I mean, I know for certain things, it's like, okay, if you add this amount of nitrogen, like at a certain point, you can add as much nitrogen as you want, and it's not going to help anymore, or potentially harm. So I was just wondering if there was any knowledge on the biomass. But thankfully, seems like at this stage, at least, there's not any big indicators.
Yeah. The more biomass you have, it can so like the crops that we found that crops that produce more biomass tend to have higher seed-to-N ratios, and if as long as in the residue. And so then that can influence residue breakdown and subsequent nutrient release. But I don't know, like that's just looking, comparing across different crops, not necessarily within a certain crop. I really don't know about
No,
that.
that's totally fine. I throw in these bonus questions and see what happens,
Okay.
and maybe an area for future research.
Yeah.
Which it seems like this is kind of a relatively new-ish thing anyway. So that's great. Wonderful. Always happy to hear about new areas to explore. So what about the seed control?
Sure. So the one thing we see is that obviously, as you delay how when you're terminating it, or seeding it earlier and just letting it go and grow, you're going to hit a point where we start producing seed. And so we found that, buckwheat produces an unbelievable amount of seed very quickly. There's almost like a little switch that happens. If we look at what we call the harvest index, which is, you can read it as a percentage, and it's the percent of the total biomass that's found in the reproductive component. So it's just calculated, reproductive biomass divided by total biomass. And for buckwheat, it basically has a harvest index of 0, and then there's a little switch and it goes up to the full harvest index, and then that stays pretty constant, which is proportional with how much biomass is there. And that value is around 40%. So right around that 6 week mark, just after that 6 week mark, we found that, it started to produce biomass, and we weren't actually able to model values below a 25% threshold for seed production, which we determined to be kind of that critical cap of what a producer might be able to tolerate. But at that 25% threshold of seed production, you're still getting, when you pencil out how much seed is there, it's something like 6 million seeds per acre, way higher than anything you'd ever be seeding. So really, we have these issues with buckwheat, in our rotations, and it's because even if you're terminating it when there's 25% seed there, a total potential seed there, it's still equating to 6 million seeds an acre. So an unbelievably high amount of seed being dumped into our seed bank that's going to stick around for a very long time. And so that really emphasizes the why we have that problem, and just kind of how rapidly the seed can start producing. We did find that if you were able to terminate it before, it's 700 growing degree days, which works out to, I think about 1200 growing degree days in Fahrenheit, that you're able to minimize viable seed production. So it's really, as you start approaching that critical amount of growing degree days, that 1300 or 700 in Celsius, you really want to think about terminating buckwheat, regardless of when it is in the season. However, we found that if you sowed buckwheat later on in August, so when it was around, 2000 growing degree days, that your likelihood of producing seed would be very low. Most of the time, we didn't get any seed production out of buckwheat seeded after that time. So as long as you're going to get that killing frost, we did get frost later on in the season in these the years of our study. You shouldn't produce any viable seed at that point.
Great. So, has this affected what your overall recommendations are for kind of the rotations and how often and when you seed buckwheat?
So it's a few things. One, we've been able to give producers kind of a better time frame of when they could potentially seed buckwheat. Like I think if you were able to get out there early enough in the season, you could potentially triple crop this, grow it, and produce anywhere between 25 and 30, 40% of biomass at each one of those crop timings, and minimize how much seed's being produced. So really, you'd be able to get below that 25% threshold. So that's one opportunity. Haven't really seen that as much, but at least we're opening up and showing that it's a potential, option for producers. One thing we are seeing is that there was a thought that if we let that first crop of buckwheat grow for just a little bit, we could get a little bit of seed production, and then we didn't have to seed it ourselves, and we just get it would seed itself through volunteering. But our model shows that really, I mean, that's a very risky strategy. I think it's definitely possible, but just the amount of seed that's being dumped into the system, way higher than anything would ever be seeding. So it will definitely work, but definitely, or you should be very conscious of the fact that you're introducing a weed into your system and it might become a problem in your subsequent potato year.
Sure. Yeah, gotta be careful with just a staggering number of seeds.
Yeah.
So, uh, we've covered a lot of ground today, but there in science is never like an end to finding more knowledge. So, what is kind of the future research and next steps for this kind of stuff?
Sure. So we've more or less presented really just a framework. So we applied it to buckwheat and applied it to this specific scenario and in our system. But any of these types of critical period studies, they need to be done in different environments. So this is relevant to Atlantic Canada, even though we've used growing degree days to try to get away from just going by this number of weeks or this many days. These studies still need to take place in different regions. Buckwheat is well adapted to our growing region, but if you look at even kind of the center of the U.S., going further down mid-Atlantic states, buckwheat doesn't produce anywhere the same amount of biomass that it can here. So it's very well adapted to our region. So other researchers could take this concept and apply it to other cover crops that are relevant to their regions. We can also extend it out to things like fall rye or other fall cover cropping. We're just focusing here on what we call full season or annual cover crops. These are green manures that are grown in the year prior to a main cash crop, which isn't really practiced in most other areas. Whenever I try and talk to this about people, they get confused and think we're talking about growing this all before potato, but like in the season right before potato, or in the season of potato, sorry. But this is all occurring in the year before. And so we can extend it out to different types of cover cropping systems. And again, just around different seeding times, different termination times. And we could very easily apply this to something like fall rye or winter wheat or one of these other fall cover crops that might be a lot more common across the US and Canada.
Wonderful. So, I have 3 questions left for you. The first one is if people want to learn more about anything that we've talked about today, where can they go?
Sure. So I work for Agriculture Canada. You can always check out any of our resources with the federal government, as well as I'm a member of the Canadian Weed Science Society. We try to get all of our information up there. So any of our fact sheets or any kind of materials that we produce would all be hosted on their website under their resources section. A lot of our cover cropping work and any of our field crop work is all funded by the Atlantic Grains Council. So they're our local producer group. They're supported by producer checkoff dollars, and they do a lot of and fund a lot of this applied research and have some really great research tools and resources all on their website. The Grains Council, as well as the PEI Potato Board and the New Brunswick Potato Board. So there again are our local commodity groups, and cover cropping is a big part of growing potatoes in our region, and so lots of different resources available on cover cropping, potato production, all available on those different websites.
Fantastic. Then for people that want to take a next step from that and get involved, whether that's as a researcher, farmer, general public, whatever, what can they do?
I think just try growing cover crops, try seeding them at different times. Try taking this concept. I'd be happy, reach out to me. I'd be happy to share any of this stuff, these models, and try and see how this model may apply to your region, your cover crop, and kind of extend it out. I'd love to see people trying this.
Fantastic. Great advice. Very practical. So then, last question. What is one fun fact about you that listeners would not know if all they had was your research?
Sure. So, yeah, I was trying to think about this, and I mean, all my like hobbies and everything are just, yeah, that's not surprising. I garden and spend most of my time running around outside. But I also do a lot of like painting models and small figures and building dioramas and that type of thing. And I have 3 young kids, 2, 4, and 6, and I have kind of dragged them into that world. And so my eldest daughter loves to paint any kind of little vampire or fairies. Those are kind of her two main things. And then my son likes anything that looks like he could be a dinosaur. So they sit there. I love to paint them all up, and then we play ridiculous, silly games with one or two rules, where they throw dice around, and we don't really care what they roll on or anything. We just move figures around on the board. So that's kind of a fun thing that I get to do with my kids, and yeah, everything else I do is based in plants. So.
Sure. That's fantastic. How what a heartwarming thing. I bet those figures are very, very cute. Or epic. I don't know. I don't know what their painting style is. But this is great. Yeah. I mean, they're pretty young. It's very, very very fine motor skills on those things. Well, this has been a wonderful conversation. This has been a delight to speak to Canada's one and only weed potato guy. This has been fantastic. Talking about two crops that we don't really talk about a lot on this show, and very helpful, practical advice for growers. So thank you for all that you do and for your time today.
Thank you so much, and thank you for having me.
Thank you for listening to Field Lab Earth. More information can be found in the description below. Thank you.